So I thought I'd do this question and just make a video for it. Question for the video on Wednesday night, just to make sure everything's making sense in your head. Okay, so it involves corner geometry of the line as well as differentiation and calculus. So part one is not too difficult. It says the function f of x is given by the formula f of x is equal to x cubed plus kx squared plus 15x plus 8, where k is an integer and x is a real number. Given that f of prime of 3 is equal to negative 12, show that k is equal to minus 9, where f prime 3 is the derivative of f of x at x equals 3. So what's that saying? When I find the derivative of f of x and I sub in 3, I get negative 12. Or I get negative 12, and more importantly, whatever the value of k is, it then equals 9. So I can solve for k. So, first of all, f prime of x, when we figured that out, well, that was going to be equal to 3x squared plus 2kx plus 18. Double check, or plus 15, apologies. Plus 15. Now, it tells us that when I sub in 3, I should get negative 12. So, step 1, I'm just going to sub in 3, and then I'm going to get 3 by 3 squared plus 2k multiplied by 3 plus 15. If I simplify that, I'm going to get 27 plus 6k plus 15. And again, simplify again, I'm going to get 6k plus 42. Now, when I sub in 3, it has to equal negative 12. So this is the fact I'm going to use to solve for k. Bring the 42 over, I'm going to get 6k is equal to negative 54. Divide by 6, k is then equal to minus 9, and that is exactly what we were looking for at the very beginning. We look back up here. So that's right. So, going on to the next question. It says the function g of x is the line that passes through the two turning points of f of x, which is equal to x cubed minus 9x squared plus 15x plus 8, as shown on the previous page. Find the equation of g of x. When in doubt, break the question down into the most simple form. Find the equation of g of x. What is g of x? G of x is the line. How do we find the equation of a line? Well, the equation of a line is y minus y1 is equal to m times x minus x1. So what do we need for this? We need y1 and we need x1. I'm going to write that the right way around. We need x1 and then we need y1. We also need to find m. So to find m, we need a second point. So we're going to need x2 and y2. So in the end, what we need is 2 points. Because when we find the 2 points, we can sub it in to the equation to find the slope, and then sub everything back in to the original equation, and that'll find us that. It also tells us that it passed through the two turning points of f of x. But how do we find the two turning points? Turning points have a unique property that the slope is equal to 0. So horizontal line that passes directly through the turning point, that's going to be 0, or the slope's going to equal 0, and the exact same thing is going to be with this one here. So once we find the Sx value, we can then plug the value of x directly back in to the original equation. And what that's going to do is find the y value. So that's how we find the two turning points. The exact same thing happens up here. We find the x value, sub it into f of x, it gives the y value. So in short, we're going to have our x1 and our y1, and we're going to have our x2 and our y2. And this all comes from the fact that the slope is equal to 0. So first of all, f prime of x, well, that's equal to 3x squared plus 18x plus 15. Double checking it. 3x squared minus 18x plus 15. So that should be a negative sign. Now, we can solve this by equaling to 0. And then first of all, I'm going to divide the whole thing by 3. So I get x squared minus 6x plus 5. Solve for the x and x, the roots of 5 and 1. So we get x minus 5 times x minus 1. X is equal to 5, or x is equal to 1. Now, as I said, we're going to just sub these back into the original f of x function to find out what the corresponding y value is. So we sub in 5, we get negative 17, and we sub in 1, we got 15. In short, this leads us to find our 2 points. So we have 5 minus 17, and then we have 1, 15. Just going back up to the original graph, and remember those 2 points, I can look at the graph then, and I know that, once I get rid of all this point right here, well, that's going to equal 1, 15, and this one right here is going to equal 5 and minus 17. Now I just need to find the slope. Well, the slope, as is in the pink box, is just going to be m when we sub in the 2 points. So if I find that, I'm going to have m is equal to -8, and that's just subbing them back into it. Also, if you're worried about which one it is, you have x1, y1, you have x2, and you have y2. Now, I have 2 points, and I have my slope, so I can find my equation of the line. So g of x is going to be equal to y minus y1, which is 15, and that's equal to -8 times x minus x1, where x1 is going to be equal to 1, because I'm using this point here. Simplify all of this, y minus 15, well, that's just going to be equal to -8x plus 8. Bring the 15 over, y is equal to -8x plus 23. And this right here is my g of x. So this right here, this line, g of x, that's going to equal -8x plus 23. Now, going to the final question. Show that the graph of g of x contains the point of inflection. I've put together this sheet right here. It's all about differentiation. It's not too long, but it just has the basics in it. Scroll down to the very bottom, we have this section on point of inflection. This is when the function goes from concave up to concave down, or vice versa. To solve, we find f double prime of x to get the value of x, and then sub x back into f of x to get the value of y. It's the exact same thing as we've done for f prime of x, except here we're doing f double prime of x, where all this is the derivative of f of x. Again, whatever x is, sub back into f of x, and we get that. So, let's just do that. F double prime of x. Well, if we look back up for our equation for f prime of x, this is what we had here. So if we differentiate that, we're going to get 6x minus 18 equal this to 0, solve for x. 6x minus 18 is equal to 0. 6x equals 18, therefore x is equal to 3. Sub that back into f, and we're going to get -1. So this is the point 3 minus 1. Again, I'm not showing you me plugging it into the function because it's literally just something you stick into your calculator. So now we need to prove that this thing actually lies on the graph, or is on the line g of x. Well, g of x, that was y is equal to -8x plus 23. So I'm just going to sub the point 3 in for x and -1 in for y. So we have -1 is equal to -8 times 3 plus 23. Simplify, -1 is equal to 24, -24 plus 23. -1 is equal to not -1. Add 1 to either side, 0 is equal to 0. So therefore, g of x, I'll write it mathematically. We know that the point 3, -1 is an element of g of x. All that means is that whatever g of x is, 3 minus 1 lays on it. So that is proof that it lies in the point of inflection. What is the point of inflection? Well, the point of inflection, as I said a second ago, is the point where it goes from concave up to concave down. So if we were to draw this with a few colours on them, this right here is going to represent the left-hand side of the graph. You can see the maps to that. And then if we take the green, we have this one right here. So where the point of inflection occurs is exactly where these two lines are going to overlap. In other words, it's the other point that crosses it. So this point right here. Now, what does it mean to be concave up and concave down? To figure that out, you look at the arms of it. So we look at the arms of the green line. We have one here and we have one here. Which direction are they facing? Well, they're facing up. So this is concave up. Again, look at the other one. This arm's going down, this arm's going down, so this is concave down. So this point right here is 3, -1, and that's how we've proven what it is. So to recap, question 1, we have to use the fact that f prime of 3 is equal to negative 12. If you just sub all that in, you'll be able to solve that you get negative 9, or k is equal to negative 9. Question 2, we're finding the equation of g of x. So first of all, we need to figure out the two turning points. So it's f prime of x is equal to 0. Solve for x. Whatever value of x we have, we just sub it straight back into f, and that gives us the corresponding y values. Those y values gave us the slope, and then we just choose a point, use the slope, stick it back into the equation of a line formula, which gave us g of x. Finally, show that the graph g of x contains the point of inflection. Point of inflection is concave up, and then it changes to concave down, or concave down to concave up, depending on the function. We just find the second derivative, which is the derivative of the derivative, and then we just solve for x, and whatever value of x we get, we just sub back into f of x. So you can see all we're doing is solving for x and then subbing it back into f of x. The majority of these questions are going to be involved in that. If you're stuck, just find the derivative equal to 0, sub it back in, you get a point. It might make more sense then, but if it doesn't, you might just net yourself a few extra marks. But I hope this helps.